Hi. Okay, so in this video, I'm going to tackle a problem that was giving a lot of people trouble with the team problem solving, whatever they were called, that we were doing today, or whenever your lab day was, or I don't know, I think it was probably today. I think everyone did it. But basically the team problem solving questions. And the question went like this, and as we go through it, I'm just gonna kind of write stuff down that we can glean from it. Wait, I'm gonna take this out because we don't need it this time, but I'm gonna write in the information that we get from the question. So the first thing that the question mentions is that there's two people, the student and the brother, so I'm gonna represent them with an S and a B. The student and the brother. Wow, that's a great line, squiggly. The kinetic energy of the student is 1/2 that of the kinetic energy of the kinetic energy of the brother. So the kinetic energy of the student equals 1/2 kinetic energy of the brother. This is badly done, but it is correct. Maybe I can resize that to make that look better. Okay, kinetic energy of the student is equal to 1/2 kinetic energy of the brother. They also tell us that the mass of the student is equal to, that's a student, not 5, the mass of the student is equal to twice the mass of the brother. So then, the last thing that they tell us is that if you make the student's new velocity, if you change his velocity, if you increase it by 1.3, then you get they have the same kinetic energy. Okay, so that's 100% of the information that they give us. So how the hell do we approach this? It's actually not too bad. Okay, so the first thing that we're going to do is we're going to just use our basic not kinematic equations, our kinetic energy equations, and plug it into here. So we get the mass of the student times the velocity of the student squared over 2, right? That's the kinetic energy of the student, and that's equal to 1/2 of, well, what's the kinetic energy of the brother? Well, that's the mass of the brother times the velocity of the brother squared. Yay! And all that over 2. So what can we get from this? Well, let's plug in this. We know that this, the mass of the student is twice the mass of the brother. So let's just say 2 times the mass of the brother times b squared over 2. And that's equal to, well, 1/2, and this is over 2, so we get over 4. We know that much, right? If you don't get that, you need to review some basic algebra skills. 1/2 times whatever over 2, you get over 4. And then you get the mass of the brother times the velocity of the brother squared. The velocity of the brother squared. What do we have? What can we simplify? Well, we have a 2 in the top and on the bottom, so we can scribble those out. We also have the mass of the brother on both sides, right? So they cancel out. That's just some basic algebra stuff there. Now, oh, I'm sorry, this is velocity of the student. So now, let's put this into let's solve this for, we'll say, the velocity of the student, because it's the easiest one to put in. Let's take the square root of both of these. Square root of that whole thing. Well, what's the square root of the s squared? Hopefully you know that's Vs. Square root of any number squared is that number. So, square root of Vs squared is Vs. And that's equal to, well, what's Vb squared? What's the square root of that? Well, Vb square root of Vb squared is Vb. And then over, what's the square root of 4? That's 2. So, we found out that the student's velocity is 1/2 the velocity of his brother. So that's a useful piece of information. That seems like a good equation to have. That seems useful. And what else do we know? Well, we know that where am I? Oh, Okay. And we also know that if we instead change the student's velocity, if we increase it by 1.3, then these are equal. So we can say that the kinetic energy that the, like, I'm going to make this little mark here just to note that it's the changed one, is equal to the kinetic energy of the brother. So the changed kinetic energy of the student is equal to the kinetic energy of the brother. So what's this changed energy? Well, this is just the kinetic energy if he increased his speed by 1.3 meters per second. So let's adapt our equations to that. So we've got the mass of the student, but we already said that the mass of the student is twice the mass of the boy, so I'm just going to put that in instead. Right? We're just doing the regular mass times velocity squared over 2, but we know that the mass of the student is this right here. So I'm just plugging that in just like we did in the last part. And then we're saying that his velocity is changed, right? So we're not just going to use the Vs this time. Instead we're going to use the Vs plus 1.3. Were you wondering where that was going to come in? I hope you were. Actually, I really don't care if you were, because it's still true. So right, this is what his velocity would be if their kinetic energies were equal. And that over 2. Again, the 2's cancel out. And we'll find that these cancel out again too. And that's equal to the mass of the boy squared times the velocity of the boy squared. This is the same stuff. Velocity of the boy squared over 2. Okay. So these MBs cancel out. And now what do we have? Well, let's multiply everything by 2. So multiply this by 2 times 2. Then these cancel out. Then we're multiplying this whole thing by 2, so 2 times that. Now, let's just take the square root of the whole equation, because then we get what VB equals. We get VB, what's the square root of VB squared? It's VB. Equals, well, square root of 2, right? Whatever that is, so we'll just say root 2, times, what is VS plus 1.3 squared? What's the square root of that? Well, it's just that Vs plus 1.3. So Vs plus 1.3. Right, because the square root of anything squared is whatever's inside the square root. So now, look, we have 2 equations and 2 variables. Anyone in algebra something will be familiar with it. Now, what we're going to do is we're going to plug this into here. So let's do that. I actually didn't do this in the first rendition of this video, but when I first recorded the past 2 videos, this video and the next video, when I first recorded them, I didn't have my webcam plugged in, and my webcam is with the microphone. So I recorded 4 videos for you guys without audio, so now I'm redoing them. That's how much I care about you guys, so be thankful. But we're just copying this. We've got that right there. We're going to maybe lengthen this line a little bit. Okay, so we said that this VB is this right here, right? So let's take out that VB and let's replace it with the value that we just found out is equal to VB. Let's replace it with that right there. Okay, so now we have root 2 VS plus 1.3 over 2. Now it's just actually some really, really simple solving, actually, believe it or not. Let's multiply everything by 2, just to get rid of the fractions. So times 2, these cancel out, and multiply this times 2, so 2 times that. Okay, now what should we do? Well, let's divide everything by square root of 2. Okay, so if we divide by the square root of 2, then we divide by square root of 2, these cancel out, and now I just have this ugly 2 over root 2 fraction, which it turns out to be the square root of 1/2, but I'm not going to show you why right now, because I just don't feel like it. So, what do we have? Because this equation was kind of messy, but if you look closely, maybe rewind the video once, you'll see where I got everything from. So we've got 2 over the square root of 2 times the student's velocity is equal to, again, the student's velocity plus 1.3. So So guess what we're going to do? We're going to subtract the student's velocity from both sides. So I'm actually just going to be lazy, and I'm going to copy and paste each of these things down. So it's going to be this. Let's see if I can get one up here for a minus. So it's going to be that minus this, right? We're just subtracting this from both sides. So that minus Vs is equal to 1.3. I feel like I'm one of those serial killers who makes everything out of the like the magazine letters. Okay. So now we have this equation. We're getting closer and closer. We can say 2. Whoops. Let's just figure out what 2 over root 2 is, because that's an ugly fraction and it's annoying to write. So scientific. Actually no. Standard. So 2 square root equals that. This is the inverse function, so this turns the square root of 2 into 1 over the square root of 2. So basically, this is the value that goes right here, and it's 1.414. So, whew, that was annoying. But now I can write everything with text, which is good. So 1.414 times the student's velocity minus the student's velocity equals 1.3. And, well, this is 1 times the student's velocity, right? This is 1. So we can say that now we have 0.414 times the student's velocity, that's pretty simple math, equals 1.3. Divide everything by 4.14. Whoops, wrong. Where's my handy-dandy calculator? There we go. So we're going to take the 1.3 and divide it by 0.414. We get 3.14. So we get that the student's velocity equals 3.14. And then remember, if we scroll up a little bit, we said the student's velocity is half the brother's velocity. So then if we just double the student's velocity, we get the brother's velocity. Sorry, I can't talk right now. So hopefully that makes sense. So let's go over just kind of how we did this. We wrote down 2 equations, and actually we got this third little piece of information that we found that would help. We wrote in what our kinetic energy equations were in each case, and we turned each one into a separate equation. So we had 2 equations. We substituted one equation into the other, and then we just solved for the variable. So it's really not too bad. So hopefully that made sense. Hopefully that helps. My next video is going to be on... what's it going to be on? I think it's just going to be kind of like a general video explaining a little bit. I'm not sure. I gotta recheck what the past video was that I made. Yeah, it's a video explaining a bit about something. I forget. You'll see. And so will I. So I'll see you then.